There's a famous clip from a zoo in Georgia. A researcher sits outside a chimpanzee enclosure with a speaker and starts playing Beethoven's Moonlight Sonata. The chimps stop, not all at once, not dramatically. They just gradually go still, the way you go still when something catches your attention you weren't expecting. One of them sits down. A younger one stops grooming its companion and turns toward the sound. They don't do this when the researcher plays silence. They don't do it when he plays white noise. Something specific is happening when the music starts, and nobody in that clip fully knows what to make of it. So here's the question. When an animal hears music, what is actually going on? Not what we want the answer to be. Not the version where your dog secretly loves jazz and your parrot is an underappreciated connoisseur. What is genuinely, scientifically happening in the animal's brain when organized sound made by humans enters its ears? The answer is strange. It's better than you probably expect, and also worse, and also completely different depending on the species. The first thing to understand is that most animals experience sound completely differently than we do. A dog's hearing range extends up to about 65,000 hertz. Humans top out around 20,000. A significant portion of most music sits in a range that to a dog probably sounds like it's missing half of itself. The highs, the overtones that give instruments their texture and warmth are largely absent. The music a dog hears is not the music you hear. It's a partial version, missing the architecture that makes it feel the way it feels. Which might be why most dogs don't seem to care about most music. But then researchers started asking a different question. What if the problem isn't that animals can't appreciate music? What if the problem is that we've been playing them the wrong music?
In 2009, a psychologist named Charles Snowden at the University of Wisconsin started collaborating with a composer named David Tye. Their argument was that human music is calibrated to human biology. The tempo of most music sits around 60 to 120 beats per minute, roughly the range of a resting human heart rate. The register we find emotionally resonant matches the register of the human voice. We respond to these things because they're built from materials we already recognize from the inside. So they built music calibrated to tamarin monkey biology instead. Same emotional structure, same use of consonance and dissonance, but tuned to the frequency of tamarin calls and set to a tamarin heart rate, which is about 3 times faster than ours. When they played it, the tamarins responded. Music composed to sound threatening made them anxious. Music composed to sound calming made them calmer and more social. The effect was measurable, repeatable, and it didn't work when they played the music in the wrong register or at the wrong tempo. The tamarins were experiencing something. It just required music that was built for them. That's not a small finding. It suggests that the capacity to be emotionally affected by organized sound isn't uniquely human. It's possibly built into any sufficiently complex social species that uses vocalization to communicate. It only doesn't work when you hand an animal music that wasn't made for their body.
Birds are where people's assumptions most reliably fall apart. A researcher named Anirudh Patel has spent years studying the relationship between language and music in animals. His central argument is that the ability to synchronize to a beat requires a specific kind of brain architecture, a brain that learns by listening and that connects the auditory system to the motor system in a particular way. Almost no animals do this spontaneously. True beat synchronization, the kind where you hear a rhythm and your body just starts moving, turns out to be extraordinarily rare. The animals that do it? Mostly birds, and mostly parrots specifically. There's a sulfur-crested cockatoo named Snowball who became famous on YouTube for dancing to the Backstreet Boys. This sounds like a gimmick? It is not a gimmick. Researchers analyzed the clip frame by frame. They slowed the music down, sped it up, changed the tempo. Snowball adjusted. Not perfectly, not right away, but with a kind of lag and resynchronization you see in a human bobbing their head to a song whose tempo shifts. He was tracking the beat, actually tracking it in real time. The researchers published a paper arguing this wasn't trained behavior, it emerged spontaneously. And because parrots are vocal learners, because they have the specific auditory-motor connection that lets them mimic sounds, they also have the hardware that makes beat synchronization possible. Your dog probably doesn't have that hardware. Your parrot probably does. This is not a personality difference, it's a brain difference. Cows are an underrated case. Farmers have known for decades that cows produce more milk when music is playing. This was widely dismissed as anecdote until researchers of the University of Leicester ran the actual study. They played fast music, slow music, and silence to dairy cows for 12 hours a day over 9 weeks. Slow music increased daily milk yield by about 3%. Fast music and silence produced the same result. But the more interesting part isn't the milk. During slow music, cows showed reduced agitation, moved less, spent more time lying down. They showed the behavioral markers of reduced cortisol, the same chemical that floods a human body under stress. The music wasn't enriching their lives in any aesthetic sense, it was regulating their nervous system. Slow, predictable, rhythmic sound was doing to them what it does to a human trying to fall asleep, the same mechanism running through a different body. Whether that counts as appreciating music is a philosophical question. Whether something real was happening to them is not.
Fish were not supposed to be part of this conversation. Researchers at the University of Vienna gave zebrafish a choice between Mozart and Bach, each available from a different lever. The fish showed a statistically significant preference for Bach. When they reran the experiment with the music played through a bone conductor instead of water vibrations, the preference disappeared. The fish weren't hearing in the conventional sense. They were feeling the sound through pressure receptors running along their entire body. The music wasn't entering through ears, it was entering through skin. If a fish feels a rhythm through its body and then chooses to experience more of it, is that not a preference? We call it music appreciation in a human, partly because of the subjective experience attached to it. We have no idea what the subjective experience of a zebrafish is, but the behavior is there, the choosing is there. We just don't have a word for it that doesn't feel like either too much or too little. Elephants communicate through infrasound, frequencies below the threshold of human hearing, transmitted through vibrations in the ground. When researchers played music to elephants in sanctuary settings, most Western music produced no obvious response. But what produced the strongest reaction was music played on instruments the elephants had learned to associate with particular humans. They weren't responding to the music, they were responding to who played it. One sanctuary in Thailand has a resident elephant named Palara, who regularly walks to the fence when a specific volunteer sits down nearby with an acoustic guitar. Not when other volunteers sit at the same spot, not when the guitar is placed there without the person. The specific combination of that human and that sound produces a behavior that has no obvious explanation other than that she has formed an association between that person's music and something that matters to her. Is that appreciation? Is that preference? Is that something that deserves a different word entirely? Here's the part that's hard to fit into any clean narrative. Most of the animals in these studies are experiencing something. Their nervous systems are doing something with the information. In some cases, something measurable. In some cases, something that can't be fully explained. But we can't get inside any of them and find out if there's an experience happening alongside the physiology. If there's something it's like to be a cow hearing a slow cello, or a parrot tracking a beat, or a chimp going still when Beethoven starts. The honest scientific answer is that we don't know, and we probably won't know for a very long time. What we do know is that the chimp in that Georgia clip stopped moving and stayed stopped. Not from fear, not from alertness, not from any identifiable survival response, just stilled, in the presence of organized sound it had never heard before. We made music for ourselves. We built it from our biology, our heartbeat, our voice, our need to communicate something that words kept failing to reach. And then we played it into the world. And it turns out the world has opinions. The parrot dances, the cow relaxes, the zebrafish picks Bach, the chimp goes quiet, the elephant walks to the fence. None of them were asked. None of them signed up for this. We just started making noise, and they started responding. And what that means is still an open question that nobody working on it thinks is small.